Welcome back to XGen Investor. I'm your host, Jake James Vogel. I love using LLM AI to discuss active inference AI. I don't know, maybe I'm a sadist. I love the inconsistencies. This episode features shifting male voices, an inability to mispronounce AXIOM consistently, and I'm sure several other flaws. This is actually the first time I've used Notebook LM with just one source, Denise Holt's work, AXIOM and VBGS, Adaptive Intelligence's New Era. I'll link to it in the description below, and you should read it. I've included 2 AI podcasts in this episode. The first is a 2-minute summary of Denise's article, and the second is a deeper dive. The deeper dive is where most of the inconsistencies are. I do believe Notebook is improving their product, and it's fun to use and work with if you want to give that a shot. They've made a lot of improvements lately. But listen, you can't fully trust LLM AI. I've pointed out hallucinations in earlier episodes. They make things up and they sell it so well that it's hard to detect. They're good most of the time, but LLMs will never be perfect. This is why we need to learn about better AI that already exists today. Please read Denise's work for yourself to get a hallucination-free take on the groundbreaking work going down at Versus. Peace out, and I hope you enjoy this episode.
This is the brief on AXIOM and VBGS, a new era of adaptive intelligence. So, Denise Holt's work highlights a really big shift happening in AI. You know, for ages, AI basically meant deep learning, right? But those models, well, they're super data hungry and kind of brittle when things change. Well, the big news coming from Versus AI is a breakthrough. The Axiom model and variational-based Gaussian splatting, or VBGS. These offer a totally new path for AI that's genuinely adaptive and, get this, actually knows what it doesn't know. First off, look, this is way more than just an incremental improvement. It's a whole new paradigm. We're moving beyond just recognizing patterns to something called active inference. Think of it like AI that actively tries to understand the world, kind of like how biological systems do it. So Axiom and VBGS let AI perceive, predict, and plan on the fly, adapting even when things get messy or uncertain. Second, how do they pull this off together? Well, Axiom acts like the brain, organizing its understanding around objects, using these slots, basically containers for what an object is and its state. It learns super fast through something called variational inference, like a detective always updating their theory with new clues. Then VBGS complements this by building live 3D maps that show not just what is there, but crucially, what's still unknown and how confident the AI is about each part. It's uncertainty aware. And finally, this isn't just theory, it's showing real results. Research from Versus AI, guided by the renowned neuroscientist Dr. Carl Friston, has consistently outperformed older deep learning methods in robotics, showing real-time adaptability. This tech can turn passive digital twins, those virtual models, into truly active, intelligent tools. We're talking game-changing applications in logistics, healthcare, smart cities, and way more. So yeah, Axiom and VBGS look like huge steps toward AI that's distributed, adaptive, and constantly learning about its world.
Welcome back to the Deep Dive. You know, every so often in technology, there's a moment that feels less like an upgrade and, well, more like the very foundations are shifting. For AI, I think we are unequivocally in that moment right now. We're talking about a complete paradigm shift, really, moving beyond the deep learning and reinforcement learning approaches that have, dominated for years into something fundamentally new. Our mission today is to cut through the buzz and clarify how this isn't just an iteration, but a new era of adaptive intelligence. It's being pioneered by Versus AI's Axiom model and the complementary VBGS method. For any professional navigating the, frankly, accelerating pace of AI, ignoring these breakthroughs really isn't an option. We're here to give you a critical edge, showing how adaptive, uncertainty-aware AI fundamentally changes the game. So, okay, let's unpack this fascinating topic. For the past decade, AI has certainly captured our imaginations. ChatGPT, AlphaGo, autonomous vehicles, these systems, trained on enormous datasets, seem to promise a future of ever-increasing capability.
But for all their brilliance in specific predefined tasks, they hit some pretty hard limits, didn't they?
They absolutely did, yeah. While impressive, these systems have proven to be neither truly trustworthy nor sustainable in the long run. Despite the excitement, their fundamental deficiencies became clear. They are incredibly data hungry, immensely costly to develop and run, and surprisingly brittle when faced with the messy, unpredictable reality of real-world environments.
Brittle, that's a good word for it.
Right. The core problem is that they excel at replicating patterns, but they cannot truly reason, adapt, or operate effectively when faced with genuine uncertainty. You know, those vague unknowns that are an inherent part of our everyday life and decision-making. What's become increasingly apparent is what we might call the deep learning illusion. These models aren't intelligent in any human sense. They demand enormous data sets, struggle profoundly to generalize beyond their narrow tasks, and consume staggering amounts of energy. And crucially, they operate as if they are absolutely certain about their output, regardless of whether it's right or wrong. The system can't tell the difference, and neither can the user working with it.
Which is a huge problem for trust.
Exactly. And reinforcement learning, too, suffers from similar inefficiencies. We're talking millions of trials to learn behaviors that humans or even animals master in, well, just a few attempts sometimes.
It's like asking a brilliant chess computer to suddenly play checkers, but maybe all the pieces look like tiny, angry squirrels. It just falls apart because the rules changed fundamentally.
Ha. Yeah, that's a pretty good analogy, actually.
It's a stark contrast to biological intelligence, which, thrives in uncertainty. We learn from limited experience, we infer patterns, and update our understanding on the fly. And we plan actions that not only achieve goals, but also actively teach us more about the world. That biological intelligence learning from limited experience, adapting constantly, that's precisely the foundational concept behind active inference, isn't it?
Exactly. This profound breakthrough we're discussing today is rooted in active inference, a theory of intelligence developed by the world-renowned neuroscientist Dr. Carl Friston, who also happens to be chief scientist at Versus AI. And what's truly exciting is that AXIOM and VBGS are the first scalable implementations bringing active inference into practical application. These aren't just theoretical constructs. They enable agents to perceive, predict, plan, and continuously refine their understanding of the world in real time. Whether that's inside a robot, across an enterprise, or even throughout a global network connected by the spatial web, the principles of active inference are now, well, actionable.
And the evidence seems really compelling. Over the past year, Versus research team, led by Friston himself, has quietly and consistently outperformed deep learning and reinforcement learning baselines across every single benchmark they've entered. We were talking about everything from game world environments like Atari to complex robotics tasks needing perception, planning, adaptation, the works.
Yeah, active inference has really genuinely outmaneuvered traditional methods in these head-to-head tests. And this isn't just hype or, some purely academic success. This track record underscores the magnitude of the shift we're witnessing in AI. If we zoom out a bit, we're not simply dealing with theory here, but with a tested and validated alternative to the dominant AI trajectory. It really does signal a complete paradigm shift in how we approach machine intelligence.
Okay, so let's dive deeper into AXIOM itself. It stands for Active Expanding Inference with Object-Centric Models. What's truly captivating about AXIOM is how it fundamentally redefines thinking for AI. It's not just about patterns, is it? It's more about understanding the world in terms of discrete objects and their relationships.
That's precisely AXIOM's core distinction. Instead of processing the world as like an endless stream of pixels or tokens, it organizes its understanding around objects and their interactions. It breaks the world down into what we call slots. You can think of these as conceptual containers, basically, for individual objects. Each slot then holds AXIOM's current beliefs about that specific object, its identity, its state, like position and movement, and its relationships with other objects in the scene.
So like different files for different things it's tracking.
Sort of, yeah. To clarify, when AXIOM perceives a scene, it assigns pixels to these slots. So in a game, one slot might represent a ball, another a paddle. For an autonomous vehicle, different slots could represent another car, a pedestrian, a cyclist, and so on. AXIOM continuously updates each slot as new evidence comes in, a bit like those folders on your computer collecting info about specific projects. This slot-based reasoning lets AXIOM move beyond just pattern recognition and operate at the level of entities and their interactions. That makes it far more interpretable and adaptable.
Okay, that makes sense. And how does it handle new stuff, things it hasn't seen before?
Ah, right. A crucial aspect is how it handles new information or changes. It uses what's called a grow and merge loop. When it encounters something genuinely new, it expands its internal model by creating a new category or slot. If it later realizes, oh wait, these two categories are actually the same kind of thing, it merges them. This streamlines its learned knowledge.
So it tidies up its own understanding.
Exactly. This allows AXIOM to adapt its complexity to match the environment and, crucially, generalize from single events, like learning the effect of a collision once and then reusing that knowledge much more broadly. AXIOM achieves this through 4 clever modular building blocks working together. First, it perceives the scene by deciding which pixels belong to which object. That's its slot mixture model, or SMM. Then it identifies what kind of object each slot represents with its identity mixture model, IMM. So it recognizes, say, a ball or a block. Next, it predicts how that object will move, figuring out its motion pattern using the transition mixture model, TMM. And finally, the recurrent mixture model, or RMM, decides which motion pattern and interaction should apply to the slot at the next moment. It's essentially predicting, okay, what will this object do next, based on context and dynamic interactions.
That adaptability sounds, well, revolutionary. But with all this continuous learning and refinement, I wonder, does AXIOM ever face challenges in committing to a plan? Or how does it even decide its next moves in such a dynamic world? Does it just try to maximize a reward like older AI?
That's a really crucial distinction. While maximizing reward is, the traditional AI approach, AXIOM operates quite differently. Its breakthrough efficiency comes from using variational inference. Instead of trying to calculate the exact probability of every single hidden variable, which is computationally impossible, most of the time, AXIOM builds simplified approximations, and it continuously updates these approximations as new evidence arrives.
Okay, simplify that a bit.
Think of it like a detective forming a working theory about a case. Each new clue updates the theory, sometimes confirming earlier ideas, other times forcing a complete revision. AXIOM does the same with objects and their dynamics. It maintains a best guess and improves it constantly as more data streams in. This allows AXIOM to learn in minutes, not months, without needing massive training sets or those incredibly expensive retraining cycles. It learns and evolves as it goes, much like living systems do.
Right, learning on the job.
Yeah.
And what about planning? How does it decide what to do?
Good question. As for planning, AXIOM isn't simply about maximizing some immediate reward. Instead, it minimizes something called expected free energy. Now, this is a principle that quite elegantly balances 2 critical goals: achieving useful outcomes and reducing uncertainty about the world.
Ah, so it's not just about getting the job done, but also learning while doing it.
Precisely. It means AXIOM is both goal-directed and inherently curious. For example, a robot guided by AXIOM might decide to open a door not only to exit a room, but also to learn what lies beyond it. That information enriches its internal model for future decisions. This dual drive to succeed now and improve understanding for later makes active inference agents fundamentally more strategic and resilient than conventional AI.
Okay, so AXIOM is the brain that thinks in terms of objects and continuously refines its beliefs. Very cool. But how does it see the world? How does it perceive its environment in a way that truly understands uncertainty, not just fixed representations? That's where VBGS comes in, right?
Precisely. Yeah, to get our heads around VBGS, or variational Bayes Gaussian splatting, it helps to start with Gaussian distributions. We all kind of know the bell curve, right? Well, their real elegance here is their ability to explicitly model uncertainty. The tighter the curve, the more confident the system is. A wider curve signals more uncertainty. Simple as that.
Okay, standard statistics. How does that apply to seeing?
Right. This concept becomes visual when we consider 3D Gaussian splatting. Instead of describing objects with fixed geometric models, like meshes, 3D Gaussian splatting represents surfaces as thousands of overlapping fuzzy blobs, or splats. Each splat captures position, color, depth, and critically, its uncertainty. These splats layered together form a continuous 3D scene. Think of it like painting with soft-focused dots that sharpen up in areas where you have more evidence.
Interesting. So the picture itself shows where it's confident and where it's fuzzy.
Exactly. It allows for smooth, efficient visual reconstructions, and because each splat encodes uncertainty, the sharper versus blurrier parts, the map itself knows where it is reliable and where it still needs more data. Now, variational Bayes Gaussian splatting, VBGS, takes this a really significant step further. It applies that variational inference, those smart approximations we talked about with AXIOM, to the splats themselves.
Ah, so it's learning about the seeing part too.
Yes. Instead of building a static 3D map, VBGS continuously updates these Gaussian distributions as new observations arrive, without needing replay buffers or retraining. Like that detective refining their theory, the map becomes a working theory, adjusting with each new clue. It refines where confidence is high and clearly marks where uncertainty remains. So in simple terms, VBGS doesn't just say, here's what's in the room. It also maintains this evolving understanding of, here's what we don't know yet, and here's how sure we are about each part of the picture. This ability to explicitly model uncertainty is absolutely vital for robots, for autonomous systems, as they explore and operate in unknown or constantly changing territory.
So it's a live map that knows what it doesn't know.
Pretty much. Unlike traditional mapping techniques that build fixed representations, VBGS uses this probabilistic approach. When you combine that with AXIOM's goal-directed curiosity, you get this live, uncertainty-aware 3D map that agents can use to navigate and plan safely, even in places they've never been or where things are constantly shifting.
That's truly remarkable. So, okay, let's bring it all together. When AXIOM and VBGS work in tandem, what does this collaboration actually mean for creating a truly adaptive intelligence?
Right. So when combined, AXIOM and VBGS form a complete active inference loop. VBGS provides that live, probabilistic 3D scene, inherently processing uncertainty.
The seeing part.
Exactly. The seeing part that understands doubt. And AXIOM then reasons about the objects within that scene, predicts outcomes, and plans actions based on that rich, uncertainty-aware data. Together, they enable agents that can see, think, and adapt continuously. This integration is really what makes them such a profound breakthrough. They don't just recognize and copy patterns. They construct, test, and continuously refine their models of understanding the world as it unfolds moment to moment while they are actually acting within it.
This isn't just about better AI. It feels like a fundamentally different kind of intelligence. And I suppose the true test of any groundbreaking theory is its application. So the real-world impact of AXIOM and VBGS, is it already proving significant?
Absolutely. Versus has already showcased some incredible breakthroughs. In robotics, for instance, their research introduced a hierarchical active inference architecture. Think multiple agents operating within a single robot body. This framework enables robots to adapt in real time, plan over long sequences of tasks, and this is key, recover from unexpected problems, all without retraining.
Without retraining, that's huge.
It's a critical difference. Deep learning robots often fail completely when conditions change even slightly from their training data. Versus Tech demonstrated real-time adaptability in unfamiliar environments, actually outperforming state-of-the-art reinforcement learning systems on Meta's Habitat benchmark for mobile manipulation. This marks the first time active inference has scaled to whole-body robotic control, delivering the kind of flexibility and resilience deep learning has long promised but, frankly, struggled to deliver.
Okay, robotics is a clear win. What else?
Well, another immediate enterprise application lies in digital twins. Today's digital twins are often just passive dashboards, right? They rely on static models that quickly lag behind reality. Updates are costly, computationally heavy, and they rarely represent uncertainty well. AXIOM and VBGS completely transform this. VBGS provides those continuously updating 3D maps that highlight not only what's known, but also where uncertainty remains. AXIOM then layers on the reasoning and planning, enabling the twin for real-time simulation. It doesn't just mirror reality. It can intervene intelligently, recommending actions, testing scenarios, coordinating with other agents.
So it becomes an active partner, not just a picture.
Exactly. It solves the critical problem of keeping digital twins relevant, adaptive, and actionable in real-world complexity, where traditional methods require constant, expensive manual recalibration.
That sounds like a genuine game changer for digital twins, turning them into truly dynamic, intelligent collaborators.
But okay, the implications surely extend far beyond robotics and specific industrial applications. What about the broader enterprise and industry landscape? How will AXIOM and VBGS impact companies across various sectors?
Oh, the impact is indeed vast. Enterprises can apply AXIOM and VBGS across pretty much every layer of their operations, from industry-facing systems to
Exactly. In healthcare, treatment planning could balance immediate patient care with long-term learning about outcomes, providing dynamic adjustments that traditional expert systems just can't match. For smart cities, imagine coordinating traffic, energy, public services across thousands of distributed agents, adapting to unexpected events like sudden weather changes, which is way beyond the scope of pre-programmed systems. And in finance, market models could adapt dynamically to uncertainty rather than relying on brittle, preset rules that tend to fail spectacularly during black swan events.
Okay, those are big external applications. What about inside the enterprise?
Right, internal functions stand to be transformed too. What's more, think about marketing. Intelligent agents built on AXIOM could simulate campaign strategies as digital twins of customer journeys, refining them in real time as data streams in. That leads to much more adaptive and personalized outreach, unlike standard A/B testing, which is always looking backwards. For HR, agents could proactively predict turnover risk, optimize recruitment pipelines, balance workforce planning dynamically. This shifts HR from static reporting to real-time strategy based on evolving individual and market factors. In cybersecurity, agents could model networks as objects in relationships, continuously testing and probing areas of uncertainty to harden defenses, rather than just relying on signature-based detection that always misses novel threats.
Finding the weak spots before the attackers do.
Precisely. Even internal financial planning can evolve dramatically. Instead of, say, quarterly reforecasting, adaptive models can continuously update forecasts as markets and supply chains shift. That offers leaders a rolling, live view of risks and opportunities that static spreadsheets simply can't provide.
The common thread running through all these domains is clearly adaptability. These systems don't just follow scripts. They learn, they explain, they evolve as conditions change, even when facing entirely novel situations. It's a different philosophy.
Exactly. And stepping back even further, the broader implication here is the true power that emerges when these active inference agents interconnect across companies and systems. This happens through things like the Spatial Web Protocol, HSTP, that's the Hyperspatial Transaction Protocol for Secure Data Exchange, and HSML, the Hyperspatial Markup Language for describing things. A really crucial piece is the Universal Domain Graph, UDG, which acts like a shared dictionary, making sure all these different agents understand object identities and behaviors in the same way.
When they can actually talk to each other meaningfully.
Right. This enables seamless collaboration across global supply chains, smart cities, entire ecosystems of commerce. What's really compelling here is that this next era of intelligence likely won't be centralized in giant black box AI models like we see now. It'll probably be distributed, adaptive, and explainable, operating as networks of interoperable agents, even running out at the edge on everyday devices and autonomous systems. AXIOM and VBGS are fundamentally the first concrete steps into that future.
So this is clearly a profound shift. And for you, our listener, who might be looking to prepare for this next era of AI, what does this mean for you? I mean, how can you get ready for something so fundamentally different?
Well, one intriguing element here is that the path forward really begins with education and small-scale pilots. It's essentially making education your core strategy. This is a complete shift, you know? And even the most experienced AI professionals cannot approach this new paradigm with the old mindsets. This isn't just another tool to add to the existing stack. It's really a new foundation for intelligence itself.
So learn first, then build.
Pretty much. And there are accessible pathways to begin. Versus AI offers a no-code platform called Genius, which lets you explore active inference directly. It's a pretty accessible way to experiment with causal models and just build intuition for how active inference differs from static machine learning. For researchers, the Axiom Game World 10K codebase is available open source under an academic license. That lets you experiment and really learn how object-centric inference, variational updates, and that free entity planning actually operate under the hood.
So options for different levels of technical depth.
Right. We generally encourage people to start with a small domain-specific problem where uncertainty and changing conditions truly matter. Think about resource allocation, predictive maintenance, maybe risk assessment. These are scenarios where active inference's adaptive causal modeling can deliver immediate value that traditional methods really struggle to provide. And piloting isn't only about testing software, it's about building literacy, building understanding in this next generation of AI. Educating yourself and your teams on these principles now positions you squarely on the future-proof side of business and, frankly, your career.
What we've explored today really points towards a seismic shift in AI. Moving beyond the hard limits of deep learning and reinforcement learning into this new era of adaptive intelligence with AXIOM and VBGS, it's abundantly clear that the rules are changing.
Yeah, this represents a true blue ocean opportunity. It's an uncharted market space that's largely free from traditional competition, offering just vast potential for growth and profit precisely because it solves problems current AI simply can't address effectively. Zooming out, it's comparable perhaps to the early adopters of the internet, or mobile, or cloud computing, the ones who became the architects of the modern digital economy. This time, the scale of transformation is potentially even greater.
So the question isn't if this shift will occur, but really when, and perhaps more importantly, who will lead it. Will you be observing from the sidelines, or will you be among those defining this next era of intelligence? The time to act isn't tomorrow or someday, it is now. Those who begin today will be the ones shaping the future of intelligence. Thank you for joining us on this deep dive into AXIOM and VBGS. We really encourage you to continue exploring this crucial shift and discover how it will inevitably reshape your world.